Hello, it's Mr. Guffick here, and in this continuing series on A-level maths Edexcel exam questions, having recently looked at differentiation optimization, in this lesson I would like to look at exponentials modeling and exponentials and logarithms modeling. And so this video is going to focus on log modeling. Again, I can't emphasize this enough, a very, very popular type of question, especially for Edexcel. Comes up an awful lot. And it's although it's AS content, it comes up in both A2 and AS exams. So let's have a look at this question then. So it says the resting heart rate of a mammal in beats per minute is modeled by the equation h is equal to pm to the q, okay, where p and q are constants and m is the mass of the mammal measured in kilograms. Figure 2 illustrates the linear relationship between log to the base 10 of h and log to the base 10 of m. The line meets the vertical log to the base 10 h axis at 2.25 and has a gradient of minus 0.235. Find to three significant figures the value of P and Q. Now, they phrase these questions in various ways, depending on the particular question. And there are two different approaches to this question. One approach is to kind of like, if they give you an equation, to work backwards into the equation that we need. But the other approach is to take logs of the equation that they give. And that's the method that I prefer. So if we've got, for example, let's have a look. We have got our resting heart rate, h, is equal to pm to the q. Now, the method that I advocate and that I like is taking logs of this equation. So I'm going to write log h is equal to log pm to the q. And remember, log means log base 10. So I'm going to say that that is log h is equal to log p add log m to the q, and that's using the addition law of logs. We now use the power law of logs to bring the q to the front. Okay, so we've now got log h is equal to log p plus q log m. So we've now broken that equation down by taking logs. And at this stage, what I like to do now is I like to rearrange this equation into the form y equals mx plus c. So y is equal to mx plus c. So I write down log h is equal to, now at this point, it can be a little bit confusing because when I look at the q and the log m, I'm faced with the decision, how do I know which one is the x and which one is the m? And the answer to that comes from looking at the graph. Invariably, 9 times out of 10 in this kind of question, they give you a graph to show you what's going on. And I can see from the graph here that log to the base 10 of m is the x-axis. Okay, so that means that this is going to be the x value here. So I'm going to write log of m is going to be my x, which means that q is my m. So that's how I've decided which part is the m and which part is the x, by looking at the graph for a visual clue of what is on the x-axis. And then I've got my log of log to base 10 of p is my y-intercept. Okay, so let's review the steps. I've started off with h is equal to pm to the q. I've taken logs. Having taken logs, I've then taken that equation and I've rearranged it into the form y equals mx plus c. Okay, now I always do that irrespective of how they phrase this particular question. As I say, there are several variants of how they phrase it, but this procedure, if you do this, this is going to be really useful to you. Okay. Now, at this stage, I'm now ready to work out what my P and my Q are. So I can see that because of the way that I've taken logs, that Q is the gradient. And the question tells us that the curve has a gradient of minus 0.235. So minus 0.235 is my value of Q. And I can see from the graph as well that the y-intercept is 2.25. So that means that log to the base 10 of P is equal to 2.25. And therefore, when I now reverse the logs, I get that P is equal to 10 to the power of 2.25. Okay, let's work that out, what that is. I'm going to just get my calculator here. So 10 to the power of 2.25. So 10 to the power of 2.25 gives me 177.82. So P is equal to 177.83. That would be if I was to round it to 2 decimal places. Now, the question asks us for the values to 3 significant figures. So that is going to be P is equal to 178 to 3 significant figures. And this is already given to 3 significant figures. So I now know that my Q is equal to minus 0.235. And I know that my P is equal to 178. And so I've now got my full equation that H is equal to 178 times by m to the power of minus 0.235. And that is part A done. Okay, so just to review the steps, we took logs, we rearranged it into the form y equals mx plus c. We then compared that with the information that we were given. And as a result of doing that, we were able to find out what our P and our Q were. That should be a Q there. We found out what our P and our Q were. Okay, that's fine. So that's 3 marks done for part A. Now, the next bit. A particular mammal has a mass of 5 kilograms and a resting heart rate of 119 beats per minute. Comment on the suitability of the model for this mammal. So when they say this, all they want us to do is to literally just sub in 5 and see what we get into our equation. Okay, so we're going to say that H is equal to 178 times by the mass, which in this case is 5, to the minus 0.235. Okay, so let me work out what that gives us. So 178 times by 5 to the power of minus 0.235. So when I work that out, I find out that that is 121.94. So to 3 significant figures, that is 122. So for part B, I found out that for a 5 kilogram mammal, that the resting heart rate H is 122. Now we're asked in this question to comment on the suitability of our model, okay? And we're told that the actual resting heart rate is 119 beats per minute. And as you can see, our model is predicted 122. And if we were to kind of like do a rough ready reckoning calculation to see how far out we are, if I was to do 199 divided by 122, you can see that I get 0.975. So we're only like 2.5% out from the actual answer. So I think what we're going to say is that this is in fact an appropriate model, okay? Because the value that our model is predicting is quite close to the actual value. So we're going to say that this is an appropriate model, okay? And then we should write down that it is an appropriate model as well. Okay, that's perfect. So that's part B done. That was a nice 3 marks, I think. Part C, let's have a look at that. Now, with reference to the model, interpret the value of the constant P. Now, this really confuses people very often in this particular question, because most often you might think that, I think people instinctively would want to think that this is the initial heart rate of the mammal or something like that, because very often in these logarithm modeling questions, that is the kind of thing that we would be after. However, in this case, that is not the case. So what the clue to this is we need to look at our equation. Okay, so our equation is H is equal to 178 times m to the minus 0.235. Now, and this, remember, is H is equal to P m to the Q. Now, hopefully you would agree with me that if in this equation we had a mass of 1, then that means that our equation would become H is equal to 178 times by 1 to the minus 0.235. And 1 to the minus 0.235 is just 1. So therefore, we would have H is equal to 178. So what the significance of the P is in this particular equation is that it's the resting heart rate of a mammal that has a mass of 1 kilogram. Okay, so it is the resting heart rate of a mammal with a mass of 1 kilogram. Okay, so not the most obvious thing in the world, that one, I don't think. But keep an eye out for that, because that's certainly, I've seen that particular theme come up in more than one question of this type. I think another question, if I remember correctly, is about the length of a pendulum swinging, and actually the meaning of one of the constants was it was the period of a pendulum that had a length of 1 meter. So rather a similar idea to what we've done here. Okay, so because the m is the variable in this equation, when we've got a mass of 1, we end up with a heart rate for the mammal of 178. So it is the answer to the question is the significance of the value p is it's the resting heart rate of a mammal with a mass of 1 kilogram. Okay, I hope that you found this this video useful rather, and I will see you in the next video.